Hello, everybody, and welcome to the Eclipse 2024 Solar Science in Action webinar of AMS Weatherband's 2024 Jamposium with Dr. Gordon Emsley, Dr. Nathaniel Frizzle, Dr. Laura Pedicolis, and our moderator, Dr. Janine Fisher. Before we begin today, I would like to make sure that everybody is aware of kind of the ground rules that we have for our webinars. First, if you have questions during the webinar, please feel free to take advantage of the Q&A option at the bottom of your Zoom screen. If you click on that, you'll be able to enter questions that you would like for our experts to address. We will also have some specific time for these questions from the audience, so we'll address them at the end of the presentation. However, in the course of the presentation, if there's an opportunity to answer a question that fits in the flow of the presentation, they'll address it at that time. And you are welcome, though, to submit questions throughout the presentation. You don't need to wait until the end. We'll just keep a running tally of the questions that come up. But now I would like to introduce today's moderator. Thank you for joining us, Janine. Janine Fisher is a program scientist in the NASA Heliophysics Division. Throughout her career, Janine has worked with government, industry, academia, and international organizations to improve space weather science and services to build the resilience of our nation to space weather impacts. She is a former commissioner of the AMS Scientific and Technological Activities Commission, or STAC. So Janine, thank you very much for joining us today.
Great, thanks, Gideon. Hello, everybody, and welcome back to the Weatherband Jamposium. I'm Janine, your moderator for this segment, and I'm excited to introduce our next topic on the Eclipse 2024, Solar Science in Action. With the upcoming total solar eclipse on April 8th, you can get involved with a number of citizen science projects, which are collaborations between scientists and members of the public. Citizen scientists have helped make important science discoveries. And as we highlight at NASA, the upcoming total solar eclipse is part of the Heliophysics Big Year, which is a global celebration of solar science and the sun's influence on Earth and really the entire solar system. So this session today will highlight some Eclipse citizen science projects and how you can get involved. So I'd like to now introduce our first speaker, Dr. Laura Pedicolis, who's an Associate Director of Edion STEM Learning at Sonoma State University, where she works to engage teachers, high school students, and undergraduates, and the public in Earth and space science. With a PhD in physics focused on the aurora and over 20 years of experience in education, her activities focus on participatory experiences using coding, electronics, experimental design, and research. In her free time, she enjoys being physically active outside with her family, friends, and pets. So Laura, thank you for joining us today.
Thank you, Janine. It is a pleasure to be here today, and I am going to share my slides. So if you can bear with me while I get those started. Okay. All right, so I'm here today to tell you about a project that I'm leading with a wonderful team at Sonoma State University and the University of California, Berkeley, as well as NASA. This is a NASA-funded project. And we work with volunteers to help our project study the changes in the sun's atmosphere and the corona. Specifically, we're looking at these things called plasma jets. And today I'm mostly going to just talk to you about the photo team. So if you're interested, by the end, I'll show the slide again. So let me just go to the next slide. For our project, you do have to be in this path where the moon shadow is going to cross North America, and that's this April 8th path. So if you're in one of these locations under this path, then you could participate in our project. I wanted to show a series of photographs taken by a photographer in 2020 for a total solar eclipse, so that you get a little bit of a sense of what the photographs end up looking like. You have to have a pretty large lens, usually somewhere between 300 millimeters and 500 millimeters. And you can see at the top row, this is the partial solar eclipse that would happen before totality, or the total solar eclipse. And then when the moon completely covers the sun, as it's doing that, you'll see these bright these bright spots. Those are called Bailey's beads. And then you have the total solar eclipse, where you can then finally see the atmosphere of the sun, because the bright photosphere of the sun is completely blocked by the moon. And so here again at the end is the partial solar eclipse. So if you aren't in one of those, in that path that I showed in the previous slide, then you will only see these partial eclipses. So the moon will just partially block the sun and then recede from it. But that's, if you aren't able to make it to the total, this path of totality, as we call it, you can still have fun with shadows. So this is just one activity that a lot of people do during a partial solar eclipse. You can pull out colanders and you'll see the sun's image. The sun moon image will go through these holes and be projected onto a wall or the ground. And you can see here, this is a picture that my sister took, I think it was actually my brother-in-law, took of the partial eclipse in October. And these are colander pictures that we took in October as well. But if you are in the path of totality, then it will go from daylight to this kind of dusk feeling. So I wanted to just give you kind of a sense of what that looks like. And here's when the sun is completely blocked by the moon. And if you're at 99% blocked, it will still look more like daylight. So you really want to get into 100% blocked if possible. These are some of our volunteers from 2017 when we did this project. So we also worked with volunteers in 2017. They brought their own photographer, their own cameras. So here's, you can see here, this woman has a nice zoom lens on her camera with a tripod. And here are some more pictures of more volunteers from 2017. Who many of these volunteers from 2017 are going to join us in 2024 as well. So if you're in the path of totality with clear skies, the solar eclipse will include phases as shown below. So this is similar to what I showed before, but it's without the little clouds. So you might have seen some clouds in the previous picture. What I liked about this diagram is that you need to have eye protection, and also your camera needs to have protection during these partial phases. When the moon completely covers the photosphere of the sun, then the solar corona can be seen. You need to actually take off all the filters on your camera and your eyes, or you won't see this very dim atmosphere. And it's just a spectacular sight to see. And then you can use some audio support to make sure that you get your solar viewing glasses or eclipse glasses back on and your filters back on your cameras. I wanted to show you what's called a high dynamic range image that we created with the 2017 photographs. This is basically many different exposures so that we can get all the different aspects of the corona in one picture. And so you can see here, this was actually the very beginning of this really cool thing, a solar storm called a coronal mass ejection. And we started doing some research with that, with those images. Here you can see another high dynamic range image, HDR image from our project in 2017. And we would take these images and we started subtracting them to try to find things that were changing in our images. If you don't know what it means to subtract images, that's okay. And then here, some of our scientific colleagues, Hano Aka et al. In 2018, they did a similar thing with cameras and photography and subtracted those images, and you can see these features in the solar corona that are changing over time. These are these solar jets up here on the top, and you see a solar plume down here. It has the number 6 next to it. So we were looking to see if we could see that in our data. And what you might see on the right is our Eclipse Mega Movie data. This is from the 2017 eclipse processed in 2022. And why I wanted to show you this is you can kind of see that our picture isn't as nice as this picture on the left. And that's in part because we didn't get calibration frames from the volunteers in the first year. So this year we're trying to get calibration frames as well, which are called flats and darks. And if you join our project, then you'll get to learn all about those and take them as well. So this is my final slide. Again, just showing you that this is the QR code. You can go to our website also just by typing in eclipsemegamovie.org. We'll make all final selections on March 18th. We do have multiple types of volunteers. We have those who already have tracking mounts, who are following that tracking mounts that allow their camera to follow the sun's motion, apparent motion across the sky, and who want to take those calibration frames. And those are, we call them the stars. But we also will be accepting any photographs that are taken with a DSLR or mirrorless DSLR, a digital camera, basically, with a 300 millimeter lens or higher. Okay, and that is the end of my slides deck.
Great. Thank you so much, Laura. So we do have time for a couple of questions, and then we'll have to save time for most of the questions at the end. But you did get two while you were speaking, so I'd like to address these to you. The first one was, I have a telescope, but not a protection lens for it. Where would I get a good quality one?
For a telescope, you would want to go to the company where you bought your telescope, and then you want to get an Eclipse filter for it. There are camera stores that may also have it. It really is a matter of getting the right diameter. And there's a nice feature that people are finding where they're making magnetic filters so that you can quickly pull it on and off. And so you might look for that option as well.
Okay, great, thank you. And then next question is, why are citizen science observations still useful for these observations, even though NASA has access to so many solar observing systems?
Right, that's a great question. Yeah, NASA has just a phenomenal suite of observatories out in space. And we're trying to take pictures from the ground through the atmosphere. Like, what's that about? So one of the interesting things, when you do take cameras out into space on satellites, and you try to image the corona, this atmosphere of the sun, generally sometimes there can be a little bit of a wobble in the satellite itself, and also there's diffraction around disks that are put in front of the photosphere. So for both of those reasons, the disks that block the photospheric light have to be bigger than the actual the apparent radius or diameter of the sun, and so that means you have to block the inner corona when you're out in space. NASA could do it. It would just cost so much money. They haven't done that yet. But, and so this gives us an opportunity to fill in that gap with the white light imagery. You can also get some of the data from the ground, but without the moon blocking the sun, you can only see this green light that gets through our scattered sunlight in the atmosphere. And so we're going to have a broader spectrum of light, which is called white light.
Great. Thank you so much, Laura. We do need to move on. You got a few other questions. You could respond in chat, or we could discuss them at the end. So thank you so much. I'd like to now introduce our second speaker, Dr. Gordon Emsley. He was born in Scotland and attended the University of Glasgow, earning a bachelor's and doctoral degrees in astrophysics. In addition, he has degrees in mechanical engineering, atmospheric science, and material science, and even French. He's worked as a researcher at the Harvard-Smithsonian Center for Astrophysics and at Stanford University. He has served as a professor of physics and astronomy and in several administrative roles at the University of Alabama in Huntsville, at Oklahoma State University, and most recently at Western Kentucky University. His research is in high energy solar physics, studying X-ray and UV emission from solar flares and the impact of flares on space weather. Dr. Emsley is also a licensed professional engineer, and his main interest in the weather comes from his activities as a pilot in airplanes and helicopters, and as a skydiver with 4,000 jumps and a world record for the largest free fall formation of 246 brave souls. So Gordon, welcome.
Well, thank you, Janine, for an interesting introduction. I'll pick up on one of the questions from the last talk. I said, why do we want to do citizen science when NASA has all these observatories? The project I'm going to talk to you about today, called SunSketcher, can only be done using citizen science observations, which is why I think it's so interesting. So let me share my screen here. And is everybody looking at that? Yes?
Yes, we can see it, but not in full view.
Well, you should be able to do that in just a second. There you go. So This is the SunSketcher Citizen Science Project. And this is a quote from the New York Times last year about important things you should find time to do in 2024. Vote was one of them, but this was one of the other ones that said on April 8th, go put your eclipse glasses on, go watch the sun and the moon do this eclipse. And at the end, it said, no matter where you are, download SunSketcher, an app developed by NASA to allow observers in the path of totality to capture images at different angles and contribute, and I mean contribute, to NASA's heliophysics research. And all you need to do this is a phone. And I want to emphasize that.
Yeah, and Gordon, could you put it in full slideshow mode?
Could I do what, sorry?
Could you put it in full slideshow mode? I'm also noticing like a panel on the right.
I am.
Okay.
It's probably showing the wrong screen on my computer, so I apologize.
Okay, just continue then.
Let me keep going. Okay. So these are people wearing their appropriately approved eclipse glasses, some more creatively than others. This is what the sun looks like through one. Laura already mentioned the interesting things you can do with colanders. Also, leaves on trees. You can basically watch the leaves, the twigs and branches moving, making little pinhole cameras that move around. I would also like to mention, by the way, the astronomy you can do during a total eclipse. All 7 planets will be visible in the sky during the April 8, 2024 eclipse, and some of them more visible than others. I also think it's really neat to watch, if you're at a high point, the shadow of the moon approaching you at 2,000 plus miles an hour. That's half a mile a second. I think it's something quite to behold. Most people, of course, come for this. This is totality, where the center of the sun is blocked out. You get to see the corona and chromospheric prominences and so forth. On April 8th, this is what we're going to be there for. These are the Bailey beads that Laura talked about. They are caused when sunlight passes between the low points on the moon's limb, in between the mountains, and generates initially dark gaps in the crescent where the mountains hit. But as the time evolves, they turn into more and more dark gaps till it's entirely dark, and you see bright points where the valleys are. And that's what we'll be looking at, or at least people with their phones will. So there's SunSketcher. It is a NASA-funded project. We have developed a smartphone app that we hope to release sometime in the middle of March that will allow users to take images of the Bailey beads just before and after totality, what we call second and third contact, and upload the data to a central server for later analysis. Why should we do that? And the scientific answer is it will be used to make the most precise determination ever of the size and shape of the sun. And that will tell us things about the flows within the sun that dictate the outer surface shape. And will also allow us to, believe it or not, test theories of gravity, because if you know the exact shape of the sun, you can get its gravitational potential to high accuracy and therefore test competing theories of gravity. This is what the app will look like on your iPhone or your Android phone. Here we have one of our team members in Odessa, Texas, during the annular eclipse last year, October 14, setting up their iPhone, and took 5 pictures of the advancing annular eclipse. At the top, you see the moon approaching from the top. By the middle, you see this annular ring of fire, and the moon disappears off to the bottom left. And when I'm talking to students about this, I ask them, which photograph do you think is the most useful? And believe it or not, the answer is number 4. That's number 4. Number 4 picture was featured on NASA's Eclipse website because that is a classic example of a Bailey bead right between the horns of the moon there, where most of the moon is covering the sun. You see this little shaft of light coming through where one of the lunar valleys is. We know exactly which lunar valley was responsible for that bead because we have high precision data on the lunar surface from NASA's Lunar Reconnaissance Orbiter satellite. Basically, this is how it works. Most of the time, if you look at 9 o'clock in this figure, the moon blocks the sun and you see nothing. There's a very exaggerated lunar limb profile shown in white here, and you can see at the 1 o'clock position that there is depressions where there are deep lunar valleys at that point, and you can see 1, 2, or 3, or 4 points where light will still make it through, forming the Bailey's beads. They only last a few seconds, but they contain priceless information on how big the sun is. There is the Odessa bead. There is the valley that caused it. We know that from looking at various position angles and so on. Now, I like to tell people that if the sun was slightly smaller than we think it is, that bead would not show up. The sun would not be big enough for the light to make it through the valley. If the sun was slightly bigger than we think it is, you would not only see that bead, but also a few friends. So by accurately recording how many beads you see and when they appear and disappear, we can get very precise information to within a few parts per million, in fact, on how big the sun is. I want to emphasize that we're going to use regular, ordinary phones with no filter. As Laura pointed out, you don't need a filter to catch these images during a total eclipse at second contact. The picture you're looking at was a 1/8,000th of a second exposure time, and that's what we have programmed the Sun Sketcher app to use. You will not get beautiful pictures with an ordinary cell phone picture of the sun, and people will be probably very disappointed when they see the images that we ask them to share. I want to emphasize that it's not the quality of the images that matters. It's the timing of these little flashes of light on and off. And even a regular smartphone can time images to within a millisecond, which translates to a very small distance, about 10 meters on the surface of the Earth, and to about 1 kilometer or so on the surface of the sun. This is our website, sunsketcher.org. There's a countdown timer there. At 51 days is no longer 51 days. It's more like 40. But as the eclipse approaches, we ask people to download the app. Right now, there's a yellow button at the top called Sign Up. If you click on that, you can send us your email address, and we will send you updates as to what is happening. Now, this is the bottom line. This is the message I'd like to convey. On April 8th, we hope that literally millions of eclipse watchers will become citizen scientists for 5 minutes. They will use their phone to make a meaningful contribution to a NASA science project, because every observation is unique. No two people will take pictures at exactly the same time from exactly the same location. And combine these images will allow us to construct the size and shape of the sun to an unprecedented accuracy. This is why we need the citizen scientists. This is the only way to do this. We cannot have telescopes located all on the eclipse path. As Laura said, that would cost way too much money. We ask for citizen scientists to get involved. It's the only way realistically to accomplish the goals of this project. The more the merrier. What I'm hoping for is lots and lots of people to sign up, to download the app. The app is completely autonomous. You don't have to do very much except turn it on and set your phone up on a stand and then enjoy the eclipse. But by getting more people involved, we'll get more data. But I think more importantly than that, even, we'll get more people who can truthfully say that they contributed data to a NASA science project. So please sign up. And as they used to say in the shampoo commercial, tell a friend or two. Thank you.
Great. Thank you so much, Gordon. And a reminder to folks, if you have a question, put it in the Q&A, and we'll have time for maybe a question right now, and then we'll have time at the end. So let's see. One question I have for you right now, Gordon, is could you repeat when the Sun Sketcher app will be available?
As NASA likes to say, we launched when we're ready. Right now, the Android app is completely internally tested. Right now, the folks at Google Play are doing their tests. When they've completed their tests, the app will show up. On Apple, it'll take a similar amount of time. We would expect it sometime in the middle of March. In the meantime, sign up for the updates. I want to stress that even if you downloaded the app today, it wouldn't do very much. You could look at the tutorial many, many times, but the app is programmed to only take pictures when an actual eclipse is happening in your location. So don't get too anxious. Download the app and make sure you know where it is on the morning of April 8th when you go to watch the eclipse.
Okay, wonderful. And then a follow-up question is, what if the internet on your phone does not work?
The internet is necessary to download the app and will be necessary for uploading the images afterwards. But I want to stress that during the time the images are taken, you can be in the middle of nowhere with internet outages all over the place. The app is completely autonomous. It knows from GPS signals where the phone is. It will internally calculate the interesting times that the photographs should be taken at. It automatically commands the camera to take the necessary pictures, 101 of them, and stores them on your phone. When you allow the data to be uploaded by hitting a little button that says, yes, please, that will allow us to retrieve those data when an internet connection is already becomes available. But it is absolutely not necessary to have an internet connection for the app to work during the eclipse day. So please go see the eclipse in a barren, desolate place, because they're much more interesting than they are in the middle of a city.
Great. Thank you so much, Gordon.
You're welcome.
Okay, I'd like to now introduce our third speaker, Dr. Nathaniel Frizzell, a space physicist, electrical engineer, and associate professor from the University of Scranton. Specializes in radio science and ionospheric remote sensing. He founded and leads HAMSCI, the Ham Radio Science Citizen Investigation, connecting amateur radio with professional research and earning recognition in the amateur radio community. Passionate about teaching and education, he looks forward to engaging students in courses like digital signal processing, fundamental physics, and electromagnetics, sharing his enthusiasm for radio and space science. So Nathaniel, thank you for joining us.
Thank you, Janine, and hi, everyone. Thank you very much for having me. So yes, today I'm going to talk about the HAMSCI Festivals of Eclipse Ionospheric Science, and I'm very happy to say that we're supported both by NASA and the National Science Foundation for these projects. So what is HAMSCI? HAMSCI is a Ham Radio Science Citizen Investigation, and we're a citizen science group that does more than just eclipses. We're a collective that allows university researchers to collaborate with the amateur radio community in scientific investigations. And so that might lead you to ask, well, what is amateur ham radio? And it's something many people have heard of, but maybe don't know a lot about. So ham radio is a hobby for radio enthusiasts, communicators, builders, and experimenters, and we come from all ages and walks of life. There's over 760,000 hams in the United States and about 3 million worldwide. And if you study and take a licensing exam, you too can become a ham radio operator. And one of the neat things it lets you do is it lets you communicate on frequencies that don't just go in a straight line. Instead, they can travel frequencies between, say, 3 and 30 megahertz. They can travel up to the upper atmosphere, get refracted back to Earth by an electrified layer of the upper atmosphere called the ionosphere, and that lets you communicate all the way around the globe. And this is actually going to be our connection to the solar eclipse. So unlike the other two experiments you heard about today, the ham radio operators aren't going to be looking at the eclipse with their eyes or with cameras. We're going to be remotely sensing how it affects the upper atmosphere with our radio waves. And this works even if you're not directly under the eclipse path, and it works even if it's cloudy out, which is really nice about this. So how is it connected with the eclipse exactly? So in this ray trace diagram, we're sending a 14 megahertz radio wave out. This is where the transmission is happening, and then this is distance away, say going from 0 to 2,500 kilometers. Along this axis is going up to the sky from 0 up to about 500 kilometers altitude. And the colors here represent plasma frequency or the electron density in the upper atmosphere. So between about 200 to 300 kilometers altitude, you get a region of ionized gas, a plasma, that is called the F region ionosphere. Now, the reason this occurs is because ultraviolet and X-ray energy from the sun photoionizes the neutral particles and creates this electrified gas. It's this gradient in electron density that causes the radio signals between 3 and 30 megahertz to refract back to Earth. When the sun goes away, the photoionization stops and the electrons will find positive ions and become neutrals again, and the ionosphere will become weaker and the radio signals will change. So normally this happens with a day-night cycle, but during the eclipse is going to cause that shadow of the eclipse will stop the photoionization and cause the radio signals to change paths. So here's a movie where I'm going to play. This is a simulation of the 2017 eclipse on 14 megahertz going from Florida to Wisconsin. And you can see now the eclipse is occurring, the ionosphere gets weaker, and the radio waves bend less. When the eclipse is over, the signals come back. The red line you see here means that the computer is predicting the station in Florida can talk to the station in Wisconsin. So again, there's the eclipse, the signal goes away, and then the signal comes back. So how do we interact with this with ham radio and with HamSci? Well, we actually have many different experiments. If you go to hamsci.org/eclipse, you can learn about all of our different experiments that are happening under the festivals of Eclipse Ionospheric Science. And today I'm going to talk about 2 of these experiments, one, the Solar Eclipse QSO Party, and 2, the Grape High Frequency Doppler Experiment. So what's a Solar Eclipse QSO Party? Well, a Solar Eclipse QSO Party is a QSO party, which is a type of ham radio contest. Ham radio operators throughout the year like to participate in contests where they try to make as many contacts with each other as they can within a set amount of time, following a set number of rules, and they keep track of all the contacts they make, and they get points for every contact they make. And then the winner, they have the most points and they get a certificate. So ham radio operators like to do this. It turns out these contests are a great way to populate the airspace, the frequencies, over a large area with these radio waves. So we're organizing our own Solar Eclipse QSO party where ham radio operators get 2 points for every Morse code or digital contact they make, 1 point for every phone contact they make, and they have to multiply their score by the number of different locations they talk to. And so this way we try to cover the United States and in the eclipse area as much as possible. There's also a number of ham radio data sources. There are these networks that are listening to ham radio operators constantly and use computer systems to automatically report back who they hear. So this becomes our data source in addition to the logs that people submit. So we actually did this in 2017, so I can give some examples of what the data might look like. This is from the 2017 eclipse. Every little black dot is a ham radio Morse code transmitting station. Every blue star is an automatic receiving station, and every colored point is a halfway point between a transmitter and a receiver that was observed by a receiver. We're taking a halfway point because we're assuming that's where the ionosphere is affecting the signal. So if you look at 2017 again, from that data, we can look at, say, just the 14 megahertz or 20 meter band. These are observations that show the number of contacts that were being made per unit distance, per unit time relative to maximum eclipse. So you can see right when maximum eclipse occurred, right at 0 here, the band essentially shut down. If you go to an hour and a half before, you were able to have a lot of communications with distances between 1,000 and 2,000 kilometers away. That stayed on until about 45 minutes before, then things started to drop off. And then it's about a half hour after the eclipse, the band came back. We were able to use these observations and we were able to compare them to physics-based models to help both validate the models and understand how the radio signals are getting from one place to another. It's also interesting that the ham radio frequencies, we have access to a number of different frequencies. they don't all behave the same way during the eclipse. Some of the frequencies stop working during the eclipse. Some of the frequencies let you talk farther away during the eclipse, and some frequencies don't work before and after the eclipse, but they work during the eclipse. So by having this contest set up so that people can use different frequencies, we're able to get different observations and compare to the model in different ways. And so it provides additional information. So we're going to be having another one of these solar eclipse QSO parties for the upcoming April 8th eclipse. If you're not a ham radio operator and you want to be involved, you can go to our website, hamsci.org, and you can contact us there. We can help you to find someone who's participating in this, or you can go to ARRL.org, the American Radio Relay League, and you can find a club in your area, a ham radio club, and they might be able to help you, let you participate in whatever they're doing. We also have the HamSci Personal Space Weather Station Grape High Frequency Doppler Experiment. And the idea is that there's a transmitter run by the National Institute of Standards and Technology in Colorado called WWV. And this transmits very accurate frequency and time references on 2.5, 5, 10, 15 megahertz and others. And this signal is able to be received by stations all over the world. Again, we have the signal going up to the ionosphere and coming back down. But you can see that if the ionosphere were to move up and down in some way or some changes, that would change the path length, and that would impart a Doppler shift on this signal. If the path length got longer, the received frequency would decrease. If the path length got shorter, the received frequency would increase. Most radios can't detect these very, very tiny Doppler shifts. But if you use our Grape low-cost personal space weather station, which is frequency disciplined by a GPS disciplined oscillator, you are able to make these very precision measurements. And so we had these stations distributed all across the United States for the October annular eclipse. And we're doing the same again for the April total eclipse. And you can see the beautiful observations we're able to get from this system. This is the observation I took with the Grape system at my house. This is 24 hours worth of data on October 14th. You can see the positive Doppler shifts of dawn, where you're getting up to plus 3 hertz, around 10 megahertz. And then here's the eclipse where it goes negative. The eclipse is coming on, positive as the eclipse is leaving. And then again, we're able to put all the observations together, get a much better understanding of how the eclipse is affecting our upper atmosphere and the ionosphere. We have lots of wonderful people who are helping to make all this happen. In addition to my other university collaborators at Case Western Reserve University and the University of Alabama and New Jersey Institute of Technology, we have volunteers like these people in the New England Grape Group, and Gary McKeaton, who are helping to build these systems and get it out and coordinate everybody. So if you'd like more information, join us at hamsci.org. Thank you.
Great. Thank you so much, Nathaniel. Very interesting presentation there. Let's see. And I want to encourage people, as we've now come to the end of the three speakers, to put your questions in the Q&A, and we will answer them. I know Laura's been answering some of them in written form, so thank you, Laura. And let's see, for Nathaniel, if we have a question for you here. Let me see. I know you answered the question already about how to get involved if you're not a ham radio operator. Could you comment a little bit about how many people are involved? You talked about the range of people you're working with. I mean, how big is this effort?
That's a good question. It's hard to really get a handle on it. We had about 300 people actively submit logs during the October eclipse. We have well over 1,000 people on our listserv. We have an upcoming HamSci workshop, which will be in Cleveland and live streamed. I know we are expecting probably between 100 to 150 people there. And I can also say that, with all the hams around the world participating, back in 2017, we had a total of over 2 million data points to look at of contacts throughout the time. So there's a lot of people who are both either directly involved and know they're involved, or people who are just on the air and don't know they're involved, but we're still able to use their data.
Well, that's wonderful. And hopefully you'll have a few others after this session today.
Yes, I do hope so.
Okay, great. Okay, let's turn to just general questions now for everybody. So put them in. I do want to address one question that's in here, although I think this might be for Gordon. Perhaps it came up when you were speaking. about the shadow snakes. What can you say about shadow snakes that roll around on the ground? Yes, did you see that?
Not a great deal. I think I know what you're talking about. Shadow bands sometimes are called, when the eclipse approaches, especially if you look at the side of a white car or something, you'll see a kind of zebra stripe pattern of dark and bright stripes on it. And to the best of my knowledge, people are not entirely sure what causes that. Laura, can you add anything to that?
I don't know too much, but I don't think, well, what I've heard, so caveat, is that as far as I know, there's no scientific full explanation of it. It is thought to be related to atmospheric effects. So I think some of our atmospheric scientists at the American Geophysical Union conference, for example, they're starting to look at how the atmosphere and the ionosphere change. I mean, it's kind of what Nathaniel was talking about, but lower down in the atmosphere, you can generate some wave features due to temperature variations around the shadow, the sides of the shadows, and it's thought that that will then diffract the light through the atmosphere differently and potentially create these bands. So that's what I've talked to some scientists about, and we've hypothesized. But I think modeling that is still a task on people's to do.
Let me bring something generally up. People have talked about all these phenomena you can see during an eclipse. You can look at the sun, the corona. It's a dynamic phenomenon. The sun will be a very high level of activity this year, so there should be more chance of seeing prominences and eruptions, jets, plumes, whatever. You can also do, as I said, a little bit of amateur astronomy. All 7 planets will be visible. Mercury just above the sun. You can look at shadows. You can listen. You can see the temperature changing. You can look at what animals are doing. You look at what other people are doing. I would encourage people to develop a little checklist. You'll get about 4 minutes of totality if you're somewhere like in Dallas, for example. And that's a long time to stare at one aspect of an eclipse. I would encourage people to write down the things they want to do and make sure you devote some time to each and every one of them. Because when it happens, your brain doesn't completely function normally. You're just taken over by the whole experience. So having a little checklist, if you like, I think it would be very good to do. I want to see that. Well, write it down and make sure you devote 20 seconds to looking at, whatever it happens to be.
That's great advice, Gordon. And speaking of that, I'm curious to hear from Laura and Nathaniel as well. Like, what advice do you have for for people listening in?
I think some good advice might be to definitely find some other people who are interested in this and talk about it with them. Because one thing I've learned from doing this is there's a lot of different ways to look at the eclipse. You've heard from 3 different projects, and within these different projects, there are lots of different aspects. And so I think Gordon hit on that a little bit. So if you're working with a friend, it can make it a little bit more exciting. You can share knowledge and maybe appreciate it in multiple different ways.
Great, thank you. And Laura, what about you?
Yeah, I think just to build on Nathaniel and Gordon's ideas is when you're planning your experience, whether it's in partial, whether you're, if you can't make it to the totality, the path of totality, or if you are in the path of totality, to think about what you want to do in terms of equipment as well. So not only a checklist. The other thing that I found really fascinating in 2017 is the flowers also close. And so that's another thing to watch for. But if you are doing one of our projects or any of the others, there are several other really fantastic citizen science or participatory science projects to really plan and practice before you go, and make sure that your setup is something that will run on its own, so it's autonomous, because what you don't want to be doing is fiddling with equipment during those, especially in totality. It's less of a issue during the partials because there's a lot more time for that and you can check in, but during the 4 precious minutes, those go by so fast because, as Gordon was saying, your brain can't fathom that it's dark in the middle of the day and not in a way where you have clouds and weird things are happening, and it's just something we don't experience. So our physiological response is very fascinating, and you don't want to be fiddling with equipment. So for our project, for example, is really focused on making sure everything's automated, and so come having practiced whatever you're going to do. And I like what Nathaniel was saying too, in terms of having family and friends, and if like one person picks one project and another person picks another project, then you could get this whole suite of data for us scientists as well. So that might be another approach.
Great. And again, we still have lots of time for questions, but I'll ask another one in the meantime. If I don't see any. What is the most memorable experience you've had with an eclipse? As people are getting excited with the upcoming one, if you could just talk about your most memorable experience. So let me go to Gordon.
Well, the first one, and my experience is a little different. I watched several cloudy skies before I finally got to see a real total eclipse, and it was happened in Turkey, and it was while it got dark on the land, it was still light over the ocean. There's this very, very interesting contrast of dark sky straight overhead with bright water, ripples of water, all as far as you could see. First equal to that, I would say, is a shadow approaching. I had to learn about this one. Find a hill and look to in this particular case, it'll be southwest on April 8th. And you'll see the eclipse happening 20 miles away. And then before you know it, it's happening where you are. That shadow moves incredibly quickly. And that's, people gasp. People are like, wow, what's happening here? They're totally shocked that anything in the real world can move that fast.
Great, thank you. Nathaniel, your most memorable experience?
Yeah, so the 2017 eclipse is definitely my most memorable experience. It's the only total solar eclipse I saw, and it happened the week before my wedding. So we planned my wedding around it, and we just had a whole bunch of friends. We organized a trip down to Kentucky, and it just worked perfectly. I was amazed. The weather was great. We actually got to see the eclipse. Some of my friends got some really good photos. So it was just a super thrill to put all the effort into getting there and then actually having it work. So it was amazing.
Oh, wonderful to hear that. And Laura, what about you? And you're on mute.
Thank you. When I was 9, my family took me camping and we saw a total solar eclipse in Oregon, which tells you how old I am if you know when that eclipse is. But I remember just the thrill of this phenomenon that was so different. But really, I think I was too young to really grasp what was going on. I think more I was excited about being out. Like being outside is one of my favorite things with family and friends, as you mentioned. So that was, I think that actually is part of the joy for me of the total solar eclipse is, I love being outside anyways, and I love to take hikes and walks. And I mean, even in cities, I like to be outside and see what's going on in the city. And it just, everything's so different during a total solar eclipse. And I just remember there was, we were in Wyoming and on top of a hill, and I got to see the shadow coming at us, like Gordon was talking about. And then it just goes so dark. And I was still looking down at everything, and I saw horses going to their barns because we were in Wyoming, so there were horses there. But also the lights turn on, like all these lights in homes start turning on. And that was kind of bizarre too. And then someone reminded me to look up because I hadn't looked up yet. And I think the most spectacular thing, someone's handed me binoculars because it was safe. And I looked through binoculars and I saw the red chromosphere, and I saw these loops off of the sun, and they were so zoomed in with the binoculars, and it just made my heart stop. It was so beautiful. And it was so dynamic. It was moving and kind of pulsating. And, you just see these photographs that NASA takes. And actually, if you look at the Solar Dynamic Observatory videos, you kind of get a sense of this too. But those are videos you're watching on your screen. To see it in real life, bubbly, I mean, it gave me the chills.
Wonderful. Hearing you talk about that's exciting. Go ahead. Sorry, Gordon.
Yeah, I can pick up a couple of things that Nathaniel and Laura mentioned. One is, if you came to Kentucky, Nathaniel, to watch the 2017 eclipse, plan ahead, because Interstate 65 was like a parking lot for about 12 hours afterwards. Plan your route out. Your route in is less of a problem. People tend to trickle in, but they all leave at once. I saw an eclipse on the Big Island of Hawaii, and I want to talk about something related to that. We went one day ahead of time. We went out, as I always do, and look for the sun angles and see where I'm going to be on eclipse day. And it was foggy. And the local said, don't worry about it. It always burns off. 8 o'clock in the morning is gone. And sure enough, 8 o'clock in the morning, it was gone. I said, I'm going to go watch this somewhere else tomorrow. I said, why? It always burns off. I said, the heater that burns it off will not be functioning tomorrow. Be aware that the weather on eclipse day is not going to match the weather a day before eclipse day. If you're watching the sun in Indiana on April 8th at 2 o'clock in the afternoon, you may see lots of cumulus clouds developing. That won't happen because those cumulus clouds require solar energy to form. As the solar energy goes away, the clouds give up and die. And so it's worth scouting ahead of time, but be aware that conditions the day before the eclipse, conditions the day of the eclipse will be fundamentally different.
So Gordon, I mean, that's a great tie into the question that we got, which I'd like to hear from all of you. What are some suggested things to look at for and during the 4 minutes of totality, or even before and after? And this person's looking to make a bingo card.
I personally like standing under a tree and watching the wind blow the branches around, making a kind of an array of pinhole. It's the moving colander, and the crescent moons dance around. And it's also important to realize that after totality is over, you've still got an hour and change of partial eclipse left. So those experiences you can get before totality, you can also get after totality is over. But I personally like to see the the crescent suns, as I call them, dance around. You can look at the partial eclipse, of course, use your eclipse glasses to do that. And let me pick on something else that Laura talked about. If you're using binoculars to look at the sun during totality, please have what I call an alert person to tell you about 5 to 10 seconds before totality ends to stop looking at the sun with said binoculars. If you just look at it with the naked eye, you'll see the flash of light and probably look away instinctively. But with binoculars, you need to have a responsible person who knows when totality will end at your location and give you about a 10-second warning to put the binoculars down.
Great, thank you. Laura, what about you?
Okay, so for a bingo card, I would put, in addition to what Gordon said, I would put, if you have a zoom lens on a camera or binoculars with filters, so that block a bunch of the light to look at partial eclipse before the totality, you could also see if you could see sunspots. There's some giant sunspots right now on the sun, and we're expecting a lot of those to stick around or to be new ones because the sun's rotating. So the ones we're seeing today, well, actually, it's about the right. Anyways, they may or may not be around on April 8th, but there should be some new ones, hopefully. So that would be maybe something to see if you have the right equipment. During totality, I would say look for closing flowers, lights on in buildings. Yeah, someone just put in the questions here, the kind of dusk dawn light on the horizon. Look for stars. That's the other weird thing that happens in totality, are stars. You can see the stars because the moon has blocked the photosphere. Look for those. I would say also look for animals. Listen, as Gordon said earlier today, listen for animals making nighttime sounds or not making daytime sounds. Listen to other people. There's a lot of people. You could listen for a person. You probably don't want to put that on for a person like yelling or crying out or making some kind of exclamation. Okay, so those are all I have. Yeah, that's my list.
Great ideas there. And then Nathaniel, what about you?
Oh, I think so many have already been mentioned. I think just also feel how things are different. Are the winds changing? Is the temperature changing? I really like the idea of listening. We all think about looking at the eclipse so much. So paying attention to some of these other senses that aren't looking is something that's really useful, I think.
Great, thank you. Let's see, we have a question here. I'm not sure if this is the right session, but let's see how you all handle that. Someone's asking, how much can we trust the weather forecasters to plan the viewing spot, assuming we can obtain them a day or two prior? So how do you all handle that when you see a weather forecast? And how does that factor into, what you're doing on the day of the eclipse?
I have a project for people. 10 days ahead of April 8th, get the weather forecast for April 8th. Then 9 days ahead of April 8th, look at the weather forecast for April 8th and see how much it fluctuates in the 10 days. Any weather forecast more than 4 days out, I wouldn't believe at all. And again, be careful, especially if it's cloud cover they're talking about, because again, the heater that normally causes the convection that generates cloud activity will not be fully functional that day for several hours. So you can trust climate forecasts, it's rainy in the northwest coast of America most of the time. I get that. But I would take them with a grain of salt. If there's a large, high pressure area over your location, you're probably going to be pretty safe. Any kind of mesoscale phenomenon like a cold front or a warm front, I'd be very cautious and be flexible. Be prepared to change your mind, get in the car and drive to where the weather is better. You have a pretty good idea 2 to 3 hours ahead of time. A day ahead of time, less so. Unfortunately, it's the way the science is.
Great response on that. Let's see, we have a last question here. Let's see, what website and when can we watch the recording of this webinar? So Gideon, that one may be for you.
Thank you, Janine. So yes, as soon as we finish this webinar and I have time to process it and take care of all that, I will have it ready to go. And then it depends upon when the committee will decide when and where to put it on our website, but we will get it up as soon as possible. Maybe keep an eye early next week. We'll try to have it up there as soon as we can. And I will put the link to the webinars that we have on our website in the chat here, along with everything else for the end of the program.
Great, thank you. And I think we're at the conclusion here. I just want to thank everybody for tuning in today to listen to this webinar on the eclipse. I also want to thank our 3 speakers, Gordon, Laura, and Nathaniel today for your excellent presentations. And so Gideon, I think, do you want to close it out?
All righty. Well, thank you everybody for joining us. If you look at the chat I just sent out to everybody, there's a spiel there about our next weather band webinar for the Eclipse 2024 specifically, and that's coming up on the 2nd of April at 7 p.m. Eastern time. So just be aware of that. If you're Eclipse fanatics, that's something you're going to want to check out. And then we will have a citizen science advancing weather and climate science, one observation at a time. That's going to be our next Jamposium webinar coming up at 1:15 Eastern time. So there's a link there that you can go to join the session. And then at the bottom, if you want to find out more about Weatherband and you're not yet a member, feel free to click that link there. That tells you a little bit more about us and what our mission is in the world of weather and water and climate. And then last but not least, this is the link to our collection of webinars that we have on our website already. So if you are a member, you can access those right away. But for the general public, there's a 3-month period until the webinar does become open to the public. So feel free to check our collection though. Yeah, we even have a webinar from, I think the last time that we had a webinar Eclipse, Janine, was it, yeah, last year, right? And that should be on there as well. So if you're, again, an Eclipse fanatic, feel free to check that out. But yes, we are now at the end of our session. So Gordon, Nathaniel, Laura, and Janine, thank you so much for taking the time and making the effort to bring this to our audience. Again, for those of you coming partway through the Jamposium, so this is our second day, all Jamposium sessions will be available to Weatherband members at amsweatherband.org. We will get the recorded videos up as soon as we can, as I was saying. If you have further questions or if you want to talk about the webinar, members are welcome to discuss on the Weatherband Community Forum. For those of you who aren't Weatherband members, please, as I said, visit the link that I had put up on our chat to learn more about us. And yes, thank you all for joining us today. Don't forget to join us for Citizen Science, Advancing Weather and Climate Science, one observation at a time at 1:15 p.m. Eastern Time. And as I have also put on the chat, don't forget to check our program page. That's the best way for you to be able to join us. But yeah, that's all I have. So thank you again, everybody. Thank you, Janine. Take care, and we will see you at our next Jamposium session coming up in a bit. Goodbye, everybody.